Welcome to my channel Simple Concepts by DJ. Today we are going to discuss about a new problem that comes under the chapter sequence and series, right? So this is the problem, that is, if a to the power n plus b power n divided by a power n minus 1 plus b power n minus 1 is the arithmetic mean between a and b, then they are asking that what is the value of n. N is the term, okay, the unknown value that is being present in this expression. So what we need to do is, the general form of arithmetic mean that is existing between two terms a and b is nothing but a plus b divided by 2. But here they had brought a new expression and they are telling that this is the expression, and this expression is nothing but the arithmetic mean am that is existing between these two terms a and b. So now what we need to do is we need to equate this expression with the general form that is given to us. Okay, so the general form, what I'm going to write is nothing but a plus b divided by 2, because that is the arithmetic mean that is existing between a and b. So a plus b divided by 2. Okay, this is the general form. Here in the problem they are telling this is the expression they are using as am. So I'm equating this expression with the general form. So that will be a to the power n plus b to the power n divided by a to the power n minus 1 plus b to the power n minus 1. Right? This is how we need to start the problem. This is step number 1. So now I'm cross multiplying the terms. Okay. So if I cross multiply, it will be 2 into a to the power n plus b to the power n is equal to a plus b into a to the power n minus 1 plus b to the power n minus 1. Okay, so now what I'm going to do? Now I'm going to multiply this term with this term. Okay, so if I multiply, what will happen? You have this exponential powers, okay, of n minus 1, which will be very complicated. So in order to ease the complication, what I'm going to do is I'm going to assume this a to the power n minus 1 is nothing but a variable like x. B to the power n minus 1 is being assigned to an alphabet called y. Okay, so I'm doing it. Let x equal to a to the power n minus 1. Similarly, let y equal to b to the power n minus 1. So now what I'm going to do is, so I got this x a to the power n minus 1, y as b to the power n minus 1. So now it will be as x plus y into a plus b into a plus b. So it is very easy, okay, for multiplying two algebraic terms which is having power 1. Okay, so if I multiply x plus y with a plus b, I'll be getting by plus bx plus ay plus ax. Okay, so now the final term will be ax plus ay plus bx plus by. Now I am taking the common term outside as a into x plus y plus b into x plus y. So this is the term which I am getting. So I need to substitute this expression in terms of this. When I multiply these two algebraic terms, I'll be getting one answer. So that answer, for in place of that answer, I'm going to substitute this expression. So let's substitute it, right? So this will be a. So I'm writing as it is. So what is x? X in a problem, we have assigned x as a to the power n minus 1. So that will be a to the power n minus 1 plus b to the power n minus 1. Okay. Plus b into again x plus y. X plus y will be a to the power n minus 1 plus b to the power n minus 1. So I've arrived at the the next step. Okay, I have multiplied these two algebraic terms and this is the result. Now what I'm going to do is I'm going to multiply this a with the individual terms that is present inside the bracket. So it will be a into a to the power n minus 1 plus a into b to the power n minus 1 plus b into a to the power n minus 1 plus b into b to the power n minus 1. So now upon expansion, I'll be getting a dot. What is a to the power n minus 1? A to the power n minus 1 is nothing but a to the power n into a to the power minus 1. So that will be a to the power n into a to the power minus 1 plus a into b to the power n minus 1 can be expressed as b to the power n into b power minus 1 plus b into a to the power n minus 1 can be expressed as a to the power n into a to the power minus 1 plus b into b to the power n minus 1 can be expressed as b to the power n into b to the power minus 1. So I'm getting the term like this, right? So fine. Now here I'm going to multiply 2 with the terms that is being present inside the bracket. So that will be 2 into a to the power n plus b to the power n is nothing but 2a power n plus 2 into b to the power n. So I'm getting the term. So next step will be here a power minus 1. So a power minus 1 is nothing but 1 by a. So that will be, so a and this will get cancelled. Similarly here this b and this b inverse will get cancelled. So the terms that is being left over is a to the power n plus a into b to the power n, or I can write it as b power n minus 1, b power n minus 1 plus b into a to the power n minus 1 plus b to the power n, right? So here it will be 2 into a to the power n plus 2 into b to the power n. So I've been left out with the two terms a to the power n and b to the power n in the expression that is placed, that is in the right hand side of this algebraic form. So what I'm going to do is I'm going to take this a to the power n and b to the power n to the left hand side. So if I bring this 2a power n, here a power n, when a power n goes to the left hand side, it will be minus a power n. It will be minus a power n. So 2a power n minus a power n will be a to the power n, a to the power n. Similarly 2b power n, and this b power n comes to the left hand side, it will be negative of b power n. So 2b power n minus b power n will be b power n, okay, plus b to the power n. So I'm getting as a to the power n plus b to the power n, which is equal to, so if I get it, this a power n and b power n will go. Okay. So I'll be left out with these terms. So what I'm going to do is a into b to the power n minus 1, or you can write it as b to the power n into b power minus 1 plus b into a to the power n into a power minus 1. There is no harm, okay. See, I'm expanding the powers. So there is no harm, no value is going to get changed. So this is the value. B power n minus 1 can be expanded as b power n into b power minus 1. Similarly, a to the power n minus 1 can be expanded as a to the power n into a to the power minus 1. So now what I'm going to do? I'm going to take this a to the power n. Here also I'm having a to the power n. Right? So I'm going to take this to this side. So it will be a to the power n minus b into a to the power n into a to the power minus 1. Okay, which is nothing but, which is equal to a into b to the power n into b power minus 1, this term, minus this term, minus b to the power n. Okay, so now what I'll be getting is, see, a power n minus b into a to the power n into a power minus 1. So now what I'm going to do is, here there is a to the power n. This a power n, I'm going to express it into another form. See, instead of simply putting a power n, I can also try out a different set of expression for this a power n such that the value of a power n will not change. Okay, it remains same, it remains identical. Okay, so what I'm going to do is, I'm going to take this a power n. Okay, so if I consider this a power n here, a to the power n, I can write this a to the power n as a to the power n minus 1 plus 1. So minus, if this is the value, I'm going to write this n as n minus 1 plus 1. So the value does not change. Okay, minus 1 plus 1, if it gets cancelled, I'll be left out with only this term as a to the power n. So at any cost, my value of a power n will not change. So this is just a modification which I am applying in order to ease the complication that is being present in the problem, right? So a power n can be written as a to the power n minus 1 into a to the power 1. Now again, in the second step, what I can write as a to the power n minus 1 into this 1 can be expressed as a to the power 1, which is nothing but dot a. Okay, so a power n minus 1 into a. So similarly, this b power n also can be expressed as b to the power n can also be expressed as b to the power n minus 1 plus 1, which is nothing but b to the power n minus 1 into b. Into b power 1 is nothing but b. Okay, anything raised to the power will be the same number itself. So now what I'm going to do is I'm going to substitute this a to the power n and b power n values here. So if I substitute, I'll be getting a power n is nothing but a to the power n minus 1 into a. A to the power n minus 1 into a minus b into a to the power n minus 1, a to the power n minus 1, which is equal to a into b to the power n minus 1 minus, what is b power n? B power n is nothing but b power n minus 1 into b. Okay, this is the term I am getting. So now what I can do is I am having this a power n minus 1, here also a power n minus 1. Similarly, in this expression, I'm having b power n minus 1 and b power n minus 1. So I'm going to take the common terms outside the bracket. So a power n minus 1, I'm taking it common, a power n minus 1 as common, and the common term and the term that would be present inside the bracket will be a minus b. A power n minus 1, when it is taken common outside the bracket, the term that will be present in the bracket will be a minus b. Similarly, which is equal to, I'll use this simple bracket here. Instead of using the square bracket, I'll use the simple bracket. So it will be a minus b. Similarly, here, if I take this b power n minus 1 outside, b to the power n minus 1 outside, I'll be getting a minus b. A minus b. So this is the value I'm getting. So now what I'm going to do is, see, I've been left out with a power n minus 1 into a minus b, which is equal to b power n minus 1 into a minus b. So a minus b will get cancelled. So the resulting term is nothing but a to the power. I'm writing over here. The resulting term is a to the power n minus 1, a to the power n minus 1, which is equal to b to the power n minus 1, which is equal to b to the power n minus 1. So now I'm going to take this b to the power n minus 1 to the denominator of the left hand side. So it will be a to the power n minus 1 divided by b to the power n minus 1, which will be equal to 1. Okay, so now this can be further written as a divided by b whole to the power n minus 1, which is equal to 1 can be expressed as a by b to the power 0. Anything to the power raised to the power 0 will be 1. Okay, x to the power 0. What is x to the power 0? X to the power 0 is nothing but 1. So anything to the raised to the power will be 1. So I'm going to write this as a by b. Okay, I can write this as a divided by b raised to the power 0. So anything raised to the power is 1. Similarly, a by b raised to the power 0 will be this one. So in no way the value is getting changed. We should make sure that if we write an expression, it should be such that the previous term, the value of the previous term or the previous result should not get affected by the new expression which we are framing on the next step. So a by b whole power n minus 1 is equal to a by b whole power 0. So I have a by b as common. So only thing is the power is different. So if the power is different means what I can do is I can equate it. N minus 1 is equal to 0. So n will be equal to 1. N minus 1, I am equating the powers because a by b is common here. The term is common. So when I equate the power, n minus 1 is equal to 0. Therefore, n is equal to 1. So this is how the problem we need to work out. So they are asking us finally we need to find the value of n. So we had found the value of n. So n is equal to 1. Thank you all for watching this video. I hope this video will be very informative to you.